Welcome to SanfordFlipMath. This is PreCalculus. We are working through the Demana, Waits, Foley, Kennedy book. We are in Chapter 7. This is 7.2b, matrix multiplication. In the last video, we worked on a lot of the basic arithmetic for matrices and a lot of the terminology. So if you're just joining us, you might want to pop back to that one. This lesson is really going to just focus on matrix multiplication. We didn't do matrix multiplication on the last one because it needs its own little lesson. Matrix multiplication is weird, and you kind of need to be coordinated to do this. And so the idea is that as you look at your left hand or on the left side, things are going to be moving horizontally, while on the right side, things are going to be moving vertically. And so this gets kind of bizarre, and so you're going to have to be real patient, and I'm going to try and go slow, and we'll just do a few examples, and that'll be it. Okay? First of all, I need to tell you that the dimensions for matrix multiplication need to work in a very specific manner. Okay? Notice that the first bullet point here says an m by r matrix times an r by n matrix yield a m by n matrix. Now let me point out a couple of things here. Okay, so one of those things is notice the r has to match. That middle number must match. If they don't match, you just can't do it. Okay, and then the other thing is whatever those outside numbers are, whatever those are, that is what the answer will be, what that product is. Okay, so just for instance, okay, if we were going to do a times b, like we're looking at over here on the right hand side, okay, this is a 2 by 2 times a 2 by 3, and so notice the inside numbers match. Okay, so if I'm doing a times b, and then the outside numbers will be my answer. So in other words, when I do a times b, the answer is going to be a 2 by 3 matrix. So there are 6 numbers that are going to go in this matrix. I'm going to have 1, 2, 3, 4, 5, 6 numbers here. Okay, now here's where the weirdness kicks in. Now I tried to use words to explain what's going on in the little bullet thing in the second point, and it's just there's no convenient way to do this word-wise, so you're just going to have to follow along. And what you're going to use when you are doing the row 1 column 1 element, okay, so this is row 1 column 1, when I'm trying to find the row 1 column 1 element in the answer, I'm going to use row 1 from the left matrix and column 1 from the right matrix. And what I'm going to be doing is multiplying and adding. Now I'm going to write down kind of what I'm doing as I'm going along, and I won't always do that, but I am this time, you know, for probably most of this, because you need to be able to follow it. Okay, so here's how it goes. I'm going to do -1 times 1 plus 5 times -3. Now this is the row 1 column 1 element. Okay, so this is going to be -1 plus -15 or -16. So that's going to go right there. Seems like a lot of work to get one number, but that is how it works. Okay, so the question now is, where is this? Well, this is row 1 column 2. So I'm going to use row 1 column 2, and I'm going to do the same kind of thing. Okay, so for row 1 column 2, I'm going to do -1 times 2, find those numbers, so -1 times 2 plus 5 times 4. Okay, and when I get done with all of that, that's -2 plus 20, so 18, and that's 18 right there. Okay. Okay, so let's do a couple more. Okay, so this one is row 1, column 3. So I'm going to use row 1, column 3. Okay, so this is going to be, okay, row 1, column 3. And I don't need you to keep track of all this, but I'm going to write it down right now because I really need for you to follow what I'm doing. So -1 times 0 plus, okay, so I'm moving across this as I move down this. So -1 times 0 plus 5 times -2. Okay, so this becomes 0 plus -10 is -10. Okay, now I'm going to do a little bit of erasing here because I just need, this is getting messy, and I need you to be able to follow what's going on. Okay, okay, and I'm going to erase all of this as well. All right, so let me put this back. Okay, all right, picking up where we left off. This is row 2, column 1. So it's going to use row 2, column 1. So 2 times 1 plus 7 times -3. Okay, and you don't need to box all these numbers in here. I'm just doing that so I can keep track of what's going on and you can follow what I'm doing without seeing my hand actually in front of the screen. Okay, so this will be row 2, column 2. So I'm going to use row 2, column 2. And you don't have to do them in this order. You can do them in any order you want. The issue is just you need to keep straight where you are. Okay, so row 2, column 2. So it's going to be 2 times 2 plus 7 times 4 okay, one more to go. Okay, so this is now row 2, column 3. Okay, so row 2, column 3, 2 times 0 plus 7 times -2. So this is 0 plus -14. So -14. Okay, and we're done. That's it. I know that seems like a lot. All right, so that was A times B. Okay, now I'm going to do a little bit of erasing because we need to do B times A. All right, so B times A. Now the problem is they're not written in the right order, so I'm going to rewrite these. 1, 2, 0, -3, 4, -2, because my brain works better if I have them in order. Okay, so on the left side this is a 2 by 3, and on the right side this is a 2 by 2, and so that means that the middle numbers have to match. Well, as most of you I think are seeing, a 3 and a 2, those don't match. Can't do it. Not possible. No solution. And you can't fool me, Mr. Sanford. We can't do that. Okay? All right, so that's done. Okay, I can't do B times A. Now, one other little point while I'm here, and that is matrix multiplication is not commutative. What's that mean? Well, you're probably aware of the fact that 3 times 2 is 6 and 2 times 3 is 6, because anytime you multiply two numbers, just numbers, when you rearrange the multiplication, you get the same answer. Multiplication of just numbers, any kind of numbers, is commutative. You switch the order, you get the same answer. Not true for matrices unless you have a very specific situation happen. So matrix multiplication is not commutative, and you can see that by seeing AB and BA don't give you the same answer. All right, let's do a little bit more. And so we're going to do D times C. Now again, D times C, this is written in the wrong order, so I'm going to rewrite this. Times C. So I have a row matrix times a column matrix. Okay, and just for the record, let's do our little dance with the dimensions here. This is a 1 by 4. This is a 4 by 1. Those middle numbers match, that's good, and then the answer is going to be a 1 by 1. A 1 by 1, well, it just has a single number. So to me it's amazing that all of this gives me a single number. Okay, and so the idea is to do the row row 1, column 1 entry, the only entry. I need row 1 and column 1. Now I'm going to do the same thing. I'm going to be multiplying and adding all the way across. Okay? So negative 1 times 1 plus negative 2 times 2 plus. So this is, let me just kind of move that guy down. Okay? All right, here we are. Negative 1. So negative 25, negative 30. And we're done. Okay, so that was it for that. Okay, well let's do C times D. Okay, and C times D is a whole different story, because C times D will be a 4 by 1 times a 1 by 4, and when we do this, well, these middle numbers do match. Our answer is going to be a 4 by 4. That has 16 different answers. Well, it's still going to go quick though, because to do the row 1, column 1 entry, I'm going to use row 1 and column 1. So I'm going across this and down this. Okay, so left to right and top to bottom at the same time. So 1 times negative 1 plus, well, that's it. And then the next one, the row 1, column 2 entry will be row 1 times column 2, so 1 times negative 2. Now really what's happening is row 1 is going to hit every single one of these. So if you can spot a pattern, you can move things along a little bit. 1 times negative 3, 1 times negative 4. Okay, so that was all row 1. All right, there we go. All right, well, let's do the same idea going across. I don't want to use blue again, sorry. Going across row 2 and down for each one of these. So across row 2 and down the first column, so that'll be negative 2. Okay, this will be a good time for you to kind of just hit pause and make sure you're getting the right thing. Okay, one more to go. Yeah, I'll use blue again, that's fine. So 4 times negative 1. Okay, so it's interesting how just a column matrix times a row matrix ended up making that big old thing. Okay. All right, well, I think we have one more that we're going to do, and that's E times F. And I know it looks like a lot, but there's an interesting thing that happens here. So this is 3 by 3 times a 3 by 4. The middle numbers match. The outer numbers are what we're going to get. So we're going to get a 3 by 4. Okay, so I'm going to have 4 numbers across on 3 different rows. Okay, so I'm going to kind of work through here, and I don't want to spend my life on this. This is row 1, column 1. So I'm going to use row 1, column 1, and you're going to grow to love ones, and you're going to grow to love zeros. Okay, so I'm going to do this. I'm going to do a row here and there, or an element here and there in writing, and the other ones I'm going to kind of buzz through. So 1 times 2 plus 0 times negative 2 plus 0 times 0 is 2. Okay, so this is row 1, column 1. That's what we just did. Okay, row 1, column 1, and we just put that in the row 1, column 1 position. Okay, if I do row 1, column 2, if I do row 1, column 3, well, sorry, that was a goofy looking, sorry, times just 5, and then 0 times negative 2. Anybody want to make a wager on the next one? Okay. The next one will be 0 times 2 plus 1 times negative 2 plus 0 times 0. Row 2, column 2 will be row 2, column 2. So that's going to be negative 6, because it's 0 times 5 plus 1 times negative 6 plus 0 times 4. Okay, and I'm going to go ahead and fill in the next bunch, and because I know the answer, because I'm sweet like that. Okay, so quick little note here. Look at the interesting pattern that is in this left-hand matrix. This matrix is called an identity matrix because when you multiply by it, you get the same answer. Okay, so this actually ended up being equal to matrix F. Okay, so let me just kind of mention, identity matrix is always going to be a square matrix. It always has ones from left to right going down, and the rest are zeros. Etc. Okay, so again, the position is going to look like ones along this way, and then you got zeros and zeros. Okay, so you can have a 1 by 1 identity matrix. You can have a 2 by 2 identity matrix. 3 by 3 identity matrix is there. Whoop, sorry. 4 by 4, and this will be the last one I write. All right, kind of messy, sorry. All right, so and that's it for identity matrices. You can keep going, but it's always ones down that diagonal from left to right, and yes, it needs to be that diagonal. Okay, well, I'm going to be done at this point. That was just matrix multiplication, and it's weird. On the left side you go across, on the right side you go down, and we'll do some hand motions in class to kind of play around with this, but that's the idea. And thanks for watching. This is SanfordFlipMath, and we are done with the matrix arithmetic that we're going to do, and we'll see you in class. Thank you much. SanfordFlipMath out.